All right, so check this out. You got me smiling and stuff now, watch it. All right, so everybody, if you pay close attention, remember we just said that we can look at scientific notation like the text message and the numbers, right? Now, why did I say it's like the text message and the numbers?
Because it makes it easier to read.
Easier to read, shorten it up, makes it faster. All of those things are correct. So check this out. Sometimes you have a number that's extremely large, right? So we'll take a look at this number. All right, who can read that number for me? Who can tell me what that number is? Anybody? What's that number, Lee? Tell me what that number is.
2,357,810,735.
There you go, everybody. Come on, Lee. Come on. All right, everybody, that is exactly right. That is exactly what that number is. But sometimes people get numbers like this, and it's like, I don't feel like reading that long number. Or sometimes people get numbers like this, and it's like, what if you have to send somebody something, and this number is taking the majority of the page? I need to save some of my page space, correct? So I'm going to teach y'all how to write this number into scientific notation. So when you read a book, which way do you read?
Left to right.
Left to right. So when we read our numbers, we're going to read our numbers what? Left to right. So now what I want everybody to do is, I want them to look for the first non-zero number. What is the first non-zero number? Non-zero number. What is a non-zero number? A number that is not zero. So if we read this like a book, what's our first non-zero number? 2. You're going to draw a line right behind this 2. Look at that. Y'all see that? We're going to call this the flagpole. So this is our flagpole. At the bottom of our flagpole, we're going to make a dot. Now everybody, what I want you to understand is this dot is now our new decimal. We're creating a decimal. We got it? All right, so now we need to basically bring down everything that we see. So on this side, we'll bring down our 2. Now, once we look to the right-hand side of this decimal, we need to basically stop at our hundredths place. How many numbers behind the decimal is the hundredths place?
3.
You sure? 2. 2, so right? So this is tenths, hundredths. Now, if we're stopping at the hundredths, we need to round up. Does this 7 make this 5 turn into a 6?
Yes.
Cool, so we know this is 2.36, correct? Now, here's where I'm going to explain something. Who knows what it means to exponentially move? Anybody? Anybody want to try? What does it mean, a double A?
Skip a number.
Skip a number. In a sense, you're kind of going to the next number, so I'm not going to say you're wrong. Who can tell me what it means to exponentially move, Lee?
Move the decimal and dip to 0.
I'll go with that. So, to exponentially move is to move by the same amount. Every time. You're moving by the same amount. So, when we move through our place values, let's say I'm in my ones place, right? Well, when I move to the left, what place did I move to now?
10.
Tens. Now, when I move, what am I at?
100.
Now, when I move again,
1,000.
what am I moving by?
10.
10, right? 10 times 1 is what?
10.
10 times 10 is what? 100 times 10 is what?
1,000.
What am I moving by?
10.
I'm exponentially moving by tens. So when we put numbers in scientific notation, every time you move your place value, you're moving exponentially by 10. So that's why I'm going to put times 10. Does everybody see how I put times 10? Now I'm about to create a number line. Everybody look at my number line. All right, on the right-hand side of my 0, what kind of numbers are there? Positive. This is true. On the left-hand side of my 0, what kind of numbers are there?
Negative.
This is indeed true. So we know positive numbers go to the right, negative numbers go to the left. Correct, right? So I now need you to create what I'm going to call a flag. You're going to draw your flag to your old decimal point. Where is my old decimal point in the number 2,357,810,735? Where's my old decimal?
730.
So yeah, so at the end of the what? The end of the 5. That's my old decimal point. Because it's understood when you have a whole number, there's an understood decimal right at the end. So does everybody see how I drew a flag?
Yes.
Alright, so I'm now drawing a flag. Remember what we just talked about when we looked at our number line? What kind of numbers go to the right? Which way is my flag going?
Positive.
So do you think that once I create an exponent, it's going to be positive or negative?
Positive.
How do you know it's going to be positive?
Because the flag is going to the
Because
right.
the flag is going to the right. Now, what about my exponent? How will I know what number will be my exponent?
Negative.
How do I know what number will be my exponent?
The one that's not in the flag.
Huh?
The one that's not in the flag.
Ooh, you're close. Stay the opposite.
The ones that are in
The ones that are in the flag. How many numbers are inside of the flag?
9.
9. Let me count and verify. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 numbers inside this flagpole. So how many place values did I skip?
3.
How many place values did I skip? How many place? 9. I skipped 9 place values because there's 9 numbers inside of my flag, correct? So I know my exponent is going to be what? 9 because I moved how many place values? 9. Now my flag is going which way? So my 9 is going to be a what?
Positive.
Positive. So that means if I write this number in scientific notation, it now becomes 2.36 times 10 to the 9th power. Does everybody understand? Look how that large number was just summed up into 2.36 times 10 to the 9th power. Make sense? Does it make sense?
Yeah.
Y'all see how I just shortened it up?
Yep.
Cool. All right. What our time looking like?
6 minutes.
6 minutes. We're going to keep moving. So now I want to show y'all something. I just showed you how to take a number and put it into scientific notation. But y'all see how our exponent is positive? I'm about to show you how you're going to get a negative exponent. Watch this. Is it safe to erase this? Can I erase this? Is it cool? All right, cool. Notice I left something here. What is this?
Oh, no.
My number
Yeah.
line. Thank you. All right, so. Now, Mr. Reece is going to be honest with you. I can't tell you how to say this number. I'm not even going to pretend. Lee, can you tell us this one? I bet you can. All right, so remember what we said. When we look at the number, we read it like a book. So we start to the what?
Left.
Beginning.
The beginning, right? Which is on which side?
Left.
The left. All right, we're looking for our first what kind of number?
90.
Our first non-zero number. We're looking for our first non-zero number. What is it?
7.
So I'm going to draw my flagpole where? After the 7, right? Behind the 7. And at the bottom of my flagpole, I'm going to put my new decimal, correct? So now I'm going to drag everything what? Down. Cool. I'm going to drag everything down. So that means this is going to become 7 point what?
36.
Why 36?
Because the 9 makes the 5 turn into a 6.
So the 9 rounds up to 5.
Yeah.
Cool. I'll take it. 7.36. Now, we already said that every time we change our place value, we're moving exponentially by what?
10.
10. So what do I need to put after this?
10.
What 10? Times 10. Cool.
To the 5th power.
Why 5th power? Think about it. I got to draw my flag. We draw our flag to our what? Old
Decimal point.
decimal point. So that doesn't necessarily mean the right. Last time my old decimal was on the right because it was a whole number. My decimal ended on the right. Where's my old decimal this time?
To the left.
To the left, all the way at the front of the number, correct? So which way am I about to draw my flag? To the yes, it's the negative. I love that. But to the left. I'm looking for the word left. So I'm going to take this and I'm going to draw my flag all the way to the left. Cool. So now I drew my flag all the way to the left. What's up, Double A? You move it to the left because every time you draw your flag, you want to move it to your old decimal place. Your old decimal. Where is your old decimal? That's where you want to move it to. Where is your old decimal? Cool. Now, everybody, what is my exponent going to be?
9.
You sure? Positive?
It's gonna be
Positive. Negative 9.
Negative 9, should we count? Who said that? Somebody said something differently. What did you say? 10. How'd you know it's 10? Because you counted the numbers in the flag. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many numbers are on my flag?
10.
10. Which way is my flag going?
Left.
What kind of numbers go left?
negative.
Y'all are so genius. So what is my exponent going to be?
Negative.
So you see how small this number is? Mind you, this isn't a large number. This is a very small number. Who can tell me why this is a very small number? Go ahead.
Because whenever you go behind the decimal, the bigger the number, the smaller it gets.
My man, give me some of that. Alright, so we just made this really small number into something that's simple. So now this just became 7.36 times 10 to the negative 10. So tomorrow, guys, what we'll be doing is we'll be breaking chairs. Good job, Lee. That's what we're gonna be doing. No, tomorrow what we'll be doing is we'll be taking this skill which I've just taught you and we'll be putting it into word problems because it's rare that you'll ever be given a problem where they'll just be like, convert this into scientific notation. So the next thing that we'll do, actually correction. The next thing we'll do is we'll go from converting numbers from scientific notation back to standard form. And then we're gonna put it into word problems. Everybody good with that? We cool? Y'all got it? All right, thank you. Y'all real.
Okay.